Dear all, welcome to this new episode of the Catia TV, this time on the topic of Catia electrical engineering from requirements to manufacturing. With 33 years of experience in wire harness design, the Catia electrical portfolio offers one of the broadest solutions on the market by enabling a sophisticated end-to-end solution for the most challenging design projects. The Catia electrical portfolio covers outstanding needs from requirement engineering through to manufacturing. With included and dedicated system engineering solutions, such as traceability and requirement management, as well as a high degree of automation capabilities, the Catia electrical engineering portfolio solution promise increased quality and reduced lead time. In this webinar, subject matter experts Axel Seri, Simon Johansson, and Paham Nayebifard will be exploring the process which enables these benefits, as well as having a look at the technical aspects which make the Catia electrical portfolio to stand out. As usual, the Catia TV webinar will be held here, in this post where you are right now, in our Catia user community, and it will give you the capacity to interact in live with our subject matter experts throughout the chat. So don't hesitate to watch the webinar, and we wish you a very good day.
Hi everyone, and welcome to the session. My name is Simon Johansson, and I work as a Catia sales representative in the Nordic countries. So that is Sweden, Norway, Denmark, and Finland. Together with me today, I have Axel and Param. Axel, do you want to say a few words about yourself?
Yes, sure. Thanks, Simon. Hello, everyone. Welcome. So I'm Axel. I'm based in Toulouse, south of France. I'm part of a Catia team. I'm technical responsible for electrical and fluidic. I really thank you for attending this meeting. I hope it's going to be very valuable for you. And I'm also co-presenting today with Param. So Param, where are you sitting? What are you doing?
Hi, I'm sitting in Stockholm, and I'm part of Access team, and I'm working with electrical and fluidics here in your north. Yeah.
So in this session, I will firstly go through the challenges that we often see at companies when it comes to electrical systems. We will then move on to providing an overview of the processes which our solutions provide, followed by a slightly more in-depth view of some of these, together with seeing them in action. We will have covered a fair bit of the benefits from our solutions on the 3D Experience platform at this point, but we will also take some time to present the possibilities for our customers which are still on V5 in the following 3 sections. Finally, we will go through our approach to helping and ensuring a successful implementation of Catia Electrical for you as a company. We will here also briefly go through one such implementation, in this case, why Bombardier chose Catia Electrical. So, to start with, electrical systems design challenges. Catia Electrical comprises of solutions which are adopted by a variety of industries, which has a need for handling the complexity of wire harnesses, cables, and cable trays. Catia Electrical is very prominent in transportation and mobility, aerospace and defense, and marine and offshore industries today. And the reason for this is rather simple. These are the industries that historically use the most amount of wire harnesses in the products, and the complexity of the harnesses can be very high. It is therefore imperative to be able to model and also create manufacturing instructions in a way that minimizes errors and allows for a faster process. However, with the electrification of our society well underway, the complexity of wire harnesses and cables are increasing in a growing number of products within industrial equipment as well as high tech. Many companies in these industries are still merely using 2D representations of the wires and cables, which nowadays can lead to an excessive amount of manual work, as well as the processes being more prone to errors forming. So let's take an example here. In the automotive industry, the cost of the electrical and electronics parts of a car amounted to 30% in 2010, according to a report that was made by PwC. In 2020, this number was 33%. In 2030, this number is projected to be 50%. Of course, Catia electrical and 3D wire harnesses is very commonly used in the automotive industry already. However, it has also been common for manufacturing preparation and sometimes also design of wire harness to be outsourced in this industry, often leading to much of the work being done entirely in a 2D environment, even if the original was made in 3D. As the complexity of these wire harnesses is continuously rising, we therefore see more and more of the design and manufacturing preparation being brought in-house. Similarly with other industries, companies are starting to realize that there are solutions that are able to handle their increasingly complex electrical products. Even though they are not as complex as with a car or airplane, they are perhaps reaching a level of complexity where these industries at some point were at. So let's take a look into some of the challenges and drivers in industry that are making these changes happen. In some industries, such as trains, buses, and trucks, physical mock-ups are still used. But this is, of course, an inefficient way in terms of cost and time, so there is a drive to eliminate this stage. 3D digital mock-ups have, of course, been around for quite a while now. In fact, since Catia first worked together with Boeing to achieve this for the first time in 1987 with the Boeing 777 airplane. The electrical discipline is, however, one of the latest to be introduced in the digital mock-up. By adding the electrical aspects to the DMU, makes the design much more flexible, as it can cope much more easily with changes from the mechanical discipline, which impacts the electrical discipline. This also feeds into the challenge of the electrical discipline being dependent on the mechanical discipline before work can progress. Anticipation of design changes are sought after to be able to start the electrical design earlier and being able to adapt and update faster with recurring changes to the mechanical design. With a complex product, the amount of wires, cables, and/or harnesses can be vast. Being able to trace these components through the life cycle, from requirements and design of new products all the way to manufacturing, is therefore becoming almost a necessity to minimize human error and keeping projects on track. And if we take a step further and look at the different process steps in design and manufacturing of electrical systems, we can divide these into three sections of the given department: schematics, 3D, and manufacturing. For the overall process between these sections, we see that the most important challenge in industry is how to deal with the integration between multiple applications and improving the currently poor traceability between these. In some circumstances, there is simply no link, which results in excess manual work. And if we look at the individual sections, we then first have schematics. With these poor integrations with the applications used by the other sections, schematics on its own becomes a repetitive and error-prone process, which is slow to react to changes to the DMU. Regarding the 3D section, the integration to the 2D tool is often poor with the setup which companies are using. This includes manual work for 3D when 2D is updated, which takes a lot of time, but is also prone to human error. Finally, manufacturing. The process often used here is not associated or even entirely disconnected to the 3D DMU. So by looking at the challenges our customers are facing, we have for a long time been working on a solution which addresses these problems, which I guess we could summarize as disconnected. So what we offer with Catia 3D Experience in electrical systems design is a solution which connects these different sections on the 3D Experience platform. From being able to establish the requirements of the electrical system to 2D schematics, 3D modeling, and manufacturing, all integrated with one another. This interconnectedness also allows for full traceability and more automation in everyday tasks, such as synchronizing the 2D and 3D. This ability to more easily update the electrical system also makes it possible to start with the electrical discipline earlier in the design process, as it is not equally dependent on the mechanical side being completed, thus providing more efficient procedures to be implemented. In short, Catia Electrical Portfolios offers a full lifecycle management solution out of the box, with all information in one place, or what we call single source of truth. Thank you.
Thank you, Simon. I'm going to start with a global view that shows our process, not in detail but on a higher level. The end-to-end engineering process is based on the RFLP approach. The layers allows us to link the different disciplines together and have a unified data stream throughout. Different type of requirements can be linked to the functional layers as input to define and design the system's architecture and the electrical and electronics architecture. Today, we are focusing on the logical and the physical layers. System Schematic Designer is in the logical layer. In here, we have the net and the wiring diagrams. These can be synchronized with the 3D models in the physical layer. L2P is the tool for going from the logical layer to the physical layer. The 3D harnesses can then be flattened for manufacturing purposes, either in scale or in full scale. All this is on top of the Enovia platform, which allows a single source of truth when used by different disciplines. The data can also be used in Simulia for different types of simulations. Let's have a closer look on each of these roles. Systems Schematic Designer role allows a fully integrated way of working to create intelligent schematics. This multidiscipline schematic application can be used for wire harness, cabling, tubing, piping, and HVAC. But in an electrical context, this means that having high principle diagrams down to a very detailed wiring diagram. Intelligent schematic objects are exposed in the database, and this allows for more flexible report generation. The schematics are integrated in a global end-to-end design process where you can synchronize your 2D logical objects with your 3D physical data. Synchronization tools are able to automatically populate the 3D physical model with components defined in the schematic diagrams, or to create links between existing objects on both sides to ensure a correct electrical content of a harness. This is achieved by combining Systems Schematic Designer role with Electrical 3D Systems Designer role. ELG covers the physical design of a harness within the context of a product. This role delivers a process-specific solution that is driven by logical specifications, namely the schematics. Synchronize electrical schematics to the 3D design will improve the quality and the consistency of the design. Optimize harness bundles accurately in context and avoid the need of costly prototypes. The 3D wires and cables are automatically created and routed within the bundles to obtain exact bundle diameters and getting the wire lengths. By delivering a realistic behavior for 3D harness design in an integrated environment brings a powerful solution that reduces design time and increases the overall quality of a large-scale or even smaller electrical systems. Reusing logical information to build physical data will save time by avoiding duplicated work. All this is a part of an integrated electrical process that has tight synchronization capabilities with the schematics and the electrical harness manufacturing engineering role. This role generates a 3D flattened definition of a wire harness design to define a manufacturing harness form board. This could be done either in 2D or even in 3D if so required. In addition, it provides a set of functions to manipulate the flattened harness in a simple and an efficient way to generate the form board drawings. EMP can also automatically generate complete manufacturing documentation in scale for production. Thanks to a total integration with the electrical 3D harness design data model, any harness design change can be automatically transferred to the flattened data. The powerful synchronization tool has simplified way of working with automatic functions and simpler UI. Due to the efficient and integrated solution, any change in the 3D can be easily synchronized with the manufacturing documentation to always have the latest formal status with minimal manual inputs. And now let's take a look at a video demonstrating the end-to-end process.
To face today's electrical engineering challenges, such as increasing complexity and high levels of data distribution, the 3D Experience platform offers an integrated electrical development process.
It starts with the easy and intuitive definition of all kinds of requirements, which will be available for all stakeholders of the project to enable complete traceability throughout the whole process. Those requirements can be used in tasks to provide easy access for others to a single description which can be enriched with associated data from all people working on the process. This enables designers to have easy access to the right data without wasting time searching.
In this video, we will illustrate the addition of two more battery modules in the net diagram and wiring diagram. First of all, in the net diagram, we will place additional pieces of equipment representing the battery modules that we previously added in electrical architecture. These modules are a reuse of already existing equipment on which connectors are already defined. We place the connectors in view and we will display the pins. We are then ready to connect this new equipment. We now need to reroute the existing nets according to design changes. We create a new net from an existing module to the new module we just added. The schematics being split in 3 different sheets to allow better readability, we use off-page connectors to define the relations of the nets and later wires through the different sheets. We will also create additional nets to connect the 2 modules in series with the other existing ones in order to generate high voltage power supply. The purpose of a net is to connect equipotential points, and therefore it can have multiple extremities. We can add new extremities to an existing net from a contextual menu. So here, for example, we connect the ground and the low voltage power supply for the temperature sensors. We can add as many new extremities as needed to an existing net to distribute the signal all the way through the entire system. To connect the temperature measurement from the additional sensors, we will need more entries on the battery management system's main connector. Using the create pins function, we add 4 pins to the 20 existing ones. Then, from the contextual menu, we are able to modify the connector representation and display those pins. From the product tree, we select corresponding nets and connect them to the battery management systems with an off-page connector. As we have more than 2 extremities to a net, we need to map the off-page connectors. When we select one, we can see all the off-pages in the project that are linked to the same net and pick one to link it. In the second step, we will create the wiring diagrams based on the net diagrams to have a complete, fully detailed electrical schematics. We have already placed the equipment and the equipment connectors, which is done the same way as in the net diagrams. Then we create some harness connectors and use the Smart Connect function to attach them to their equipment counterparts. This will resize the symbol and display required pins. Here we are working with wires instead of nets. These wires have only two extremities, so the connections between wires will be done with splices. Therefore, we first place two additional splices, then create and route the new wires. While routing wires, we may select the net they are implementing. The system will be able to assist for pin selections. We select the net in the drop-down list and then connect highlighted pins. So the system is guiding the user to enhance the net diagram to a full wiring diagram in an easy and productive way. To modify the existing wire route, we disconnect one extremity of the wire from the equipment and create a new connection to the next battery module connector. We continue the wiring according to highlights of the net to wire function, and we can route the other extremity of the wire on a different page, again using off-page connectors. In this case, where the conductor has only two extremities, the off-page connectors are updated instantly by the tool. We can then stretch the disconnect through the new wires, which are automatically cut on both sides of the component and connected to its pins. We need now to assign the new components to the existing harness. So we will select the two connectors and two splices, which are now part of the global harness. The harness is a complete set of all related connectors and wires to form the wire harness assembly in the battery package. To control the design, we use the BI Essentials functions, which can check the connectivity of the complete network and the harness assignment of all components, as we can see here. Every object that we manually assign to the harness are highlighted in green. Blue objects are implicitly identified as part of the harness because both their extremities are. As only half of the disconnect is assigned to the harness, it is shown in yellow. And finally, all red parts haven't been assigned to any harness. This concludes the demonstration, where we showed the creation of the net diagram and the evolution to a detailed wiring diagram, including all connectors, disconnects, wire diameters, and so on.
In the 3D design, we are able to use the logical to physical interface to synchronize the content of the logical schematic with the 3D design. Here, we're going to place equipment and connectors from the schematic in context and smart place them into the 3D design. With the equipment and connectors now placed, we will complete the harness to connect the two modules to the already existing harness. We can hide these two modules to allow us to more easily complete the harness design and connect the new modules. We can create a new segment following the surface of the battery frame and then connecting the two segments to the two connectors, keeping the tangency at the beginning by selecting the previous segment. Also giving an estimation of what we think the diameter might be, but we can compute it later on when we have defined the wire content. So we've defined the two segments to the two connectors. Before routing, we can quickly check that the harness is properly connected with the Network Assistant function. And we can see that everything is green, so this means the harness is OK and ready for routing the wires. we will import the wire content into the harness, also provided by the wiring diagram. So we can select the wires that have been defined and then import them. This means we now have the from-to information for each wire, but they are not yet routed inside the defined bundles. The next step is to route the wires. We select all of them, and the route for each of them is calculated inside the harness. Now the system has calculated the exact length for each wire, and the bundle diameter based on the wire content is updated. By selecting a wire, you can display the properties, including the exact length that has been computed. In this video, we are generating the wire harness documentation with a new panel to facilitate the user work and completely automate the production of documentation based on company standards. It is only a matter of pushing the start button and after a little while, open the result. The system will do all the necessary checks and creation of the result, but you can still modify it afterwards if needed. Reports, like a wire list and a bill of materials, are created. You also have the drawing that you can reorganize by moving the tables that are defined, in this case, for each connector. The form board process is very similar to the documentation process. In this case, we also have a backbone. This is automatically generated by the system, but can be user controlled. It is this which provides the backbone from which all of the rest of the harness will move out from. Once the system has created the 3D form board initial shape, the user is then free to use the contextual commands to assist them in fitting the harness onto a form board. We are able to bend and control the position of harnesses as we wrap the harness onto the form board. We can also edit and change an entire branch and reference back not only to the edges of the form board but other branches as well. We have the ability to build and create multiple dimensions very easily. So once the 3D has been completed, we can then go ahead and generate a drawing in the usual manner. This drawing is again synchronized, and automatically from the company standards we can create tables and call-outs, including end of connector views, pin-out connectors, and also wire tables as we previously saw in the documentation process. We can modify the 3D in the form board. We can remove branches and connectors, and we can change features and manipulate branches. One of the powerful tools we have is a full synchronization between the 3D form board and the 3D electrical design. The synchronization command generates reports to inform and assist the user to understand the differences, if any, between the 3D design and the form board model. Once the form board model is ready, the associated drawing can be updated at the touch of a button. All the tables, callouts, wire information and bundle segment lengths are modified based on the new information in the form board model. Finally, we can see the ability to cross-reference between the 3D design and the form board model. This could be used to assist the form board designer to understand the 3D design intent.
So now let's see the different alternatives we can also consider, if not fully ready for the platform revolution. So the first one we propose is what we call the supplemental approach. In this process, we keep using the usual tool for the design, meaning Catia V5, and also the same tool for the data management. So it's keeping the PLM single source of data. But on top of this, we propose to use the 3D Experience platform manufacturing, electrical manufacturing preparation application to generate the harness drawings. So it's taking benefit of the new powerful interface, also taking benefit of enhanced capability for synchronization, which is handling complex changes in the harness structure. It's also taking benefit of the capability of reuse of existing projects to generate easily and quickly the drawings for harnesses and then to store them back into the legacy tool for data management. So nothing is changed in terms of design and data lifecycle and data management, but the drawing is generated using the platform new offer. All the synchronization capabilities are also taken into account and very powerful. So any change in Catia v5 is related into the platform as soon as we import it for new drawing updates. The second option is using the PLM collaboration services that are offered by the platform. So in this approach, his proposal is to connect on the platform in Enovia 3D Experience the different CAD that we are using. So mentioning here Catia v5 for the design of the structure of the car here, for instance, and to connect also the 3D experience for electrical system definition. So here we can use for the harness description the diagram, 3D design tool, and drawing generation of Catia electrical 3D experience. So all of this connected to the platform allows the collaboration for instance, interference checking, for bill of material management, data review, collaboration, weight and COG, weight and center of gravity, sorry. All these collaboration needs that we have, whatever is the source of the CAD that is used in the data. So this approach will allow to use the new capabilities offered in the Catia Electrical in the platform without changing all the project, without migrating the project into the new tool, but still starting with the platform collaboration. So here we see an example of a process that can be covered where we used to define the data structure, the structure of the car seat into Catia v5. Everything is stored as a second step into the platform for data review, project manager usual task, but also for the electrical designer to be able to filter the environment he needs, so to build his working session and to open everything that he needs, which is designed as well in V5, to open it in the 3D Experience platform for the electrical system definition. So you can here enrich the data with the electrical harness, with electrical diagrams, and generate the manufacturing drawing. All of this also stored into the platform and managed in the collaboration in Enovia. So any external user, any stakeholder of the process can review, of the project, sorry, can review the data, whatever is the source for the design, independently of the CAD which is used. We would like also to take the opportunity of this presentation to show you the new capabilities we have in Catia v5, on top of Catia v5. So we are here enriching the process with the capability of synchronizing better the 3D design as per the electrical information. So it's an add-on on top of Catia v5, which is proposing new functions to define more in detail the electrical information coming from the 3D design. So we have here a short video to introduce this capability. We have here a harness, and you see on top the toolbar that allows to synchronize. So here we quickly review the input information that are the electrical description of the connectivity, where we see all the wires with their properties. What will be used in Catia is mostly the extremities, which are the connectors and the connections, plus the properties of the wire, which are the diameters or materials. So here we start to synchronize the Catia definition to check what is the maturity. So first is a report to the Catia designer of the content of the electrical information. So all the connector list, all the wire list with their properties. And if properties are missing, they are here collected in blue. This new panel shows the discrepancies we have in Catia compared to this electrical definition. So here we have connectors that are in addition in Catia, not retrieved in the electrical definition. And in the opposite, in the second step, we see 3 connectors defined in the electrical definition, which are missing into Catia. So here the designer can really have a clear view of the maturity of his Catia design compared to the electrical inputs. So here, without completing any change, he knows where he is, and he can start routing the wires. So this is a panel can I say, translating the wire information in the diagram. So we see all the connectors information with their status, green if already in the session, red if missing. And as soon as the user is selecting some of them, he sees interactively a zoom in on both extremities and a filter of the wire list. And he can directly see the proposed route by the tool, taking into account the electromagnetic code, for instance. So he can really navigate here and scan the electrical data as per his design. So we can route here everything and review. So this will be the basis to collect the wire length and the bundle diameter. Here we have a second synchronization. So we get from the electrical definition a new release. So there are new information, such as the connector. The connector information have now been defined. So we have the part number or the material. So this is provided. This information is provided to the user, so he knows that the tool will propose to replace all these connectors. Also, the wire basic single core information are provided, so the bundle diameter will be calculated. And you see here that interactively, the tool is proposing to the designer to replace all the connectors with the right inputs coming from the electrical definition. So it will automatically replace, keeping all the connectivity in the design. So this allows the designer to start earlier his design, being flexible and agile at any change. So you see here the replacement. There is also one new connector that has been added on a new equipment. So here we see that the connector is added at the right place. So it's kind of a snapping. There is no connectivity here. That could be added later on if needed. So there's really an assistance to the Catia designer to put the electrical information right at the right moment. So it's helping in terms of being faster and more better in the quality. And here we have the final update, which is bundle diameter and report of wire length. There are plenty of other reports available, which are not shown here in this quick review. The final part we would like to explain here is the deployment project, the way we engage to deploy such kind of a process into a company that needs to review its electrical process. So the first step, after discussion about the company needs and drivers, plus demonstrating the Dassault Systèmes electrical solution offer, we go deeper in the specific use case, and on the way to cover them in the future with a new process through a proof of concept. So this proof of concept allows the evaluation of the gain and the cost to define also the ROI of such implementation. As soon as a go is given to the project, we enter in the implementation phase. So the project is divided in several work packages. Among them, we have the electrical process and data definition, as well as standard management and usage, and followed by the three major topics of the electrical we described earlier in this presentation, which are the electrical diagrams, the 3D digital mockup for harnesses, and the manufacturing documentation and drawing generation. And after this part, if we are adding some customization to cover specific businesses knowledge that could be under IP, for instance. So this leads to the successful deployment of the project after these 4 steps.
Okay, so I hope everyone really enjoyed this webinar and the information that was provided here. So thank you so much for joining, and we all wish you bye.
Yeah, bye-bye. Thank you, guys. Feel free to ask
Bye-bye.
your question whenever you want. Bye.